Welcome to my project on heart disease prediction using machine learning models such as random forest and neural networks. This video explains the step-by-step process of training and evaluating models to predict heart diseases based on various features like age, cholesterol, blood pressure, and ECG results. In this video, you will learn how to pre-process data for machine learning tasks, how to train a random forest model and a neural network, how to evaluate model performance using metrics like accuracy, precision, recall, root mean square error, and coefficient of determination. The goal is to understand the significance of using machine learning for early heart disease detection, which is crucial for prevention healthcare. If you find this video helpful, don't forget to like, comment, and subscribe for more tutorials on machine learning and healthcare. Let's move on. We are going to download our dataset through Kaggle. Here, I selected a dataset, heart disease prediction. I'm going to download it using here. After downloading this one, here it gives a CSV file like this. Totally, this has 271 data. The data columns of this consist age, sex, chest pain, blood pressure, cholesterol, FBS, EKG results, max HR, exercises, deep press. Like this, there are some headers. Next, we are going to first of all do this using random forest. While we are using random forest, first we are going to import pandas as PD. Then we are going to load our data set into this one. And after that, we are going to print all our columns. Here, all the columns, there are 13 columns available here. Then we are going to print the headers. Here we can see the heart disease column. It shows a string data value, presence and absence. First of all, we have to convert it into numerical data. So here I took, if heart disease is presence, it shows in 1, and if it is absence, it is shown by 0. So after converting them into numerical data, this gives the heart disease column 0, 150 data which there's absence of heart disease, and 120 data of presence of heart disease. After that, we are going to plot our graph. The X will label the heart disease, the presence or the absence. Blue color depicts the absence and the red color is presence. The Y axis shows the count. This is the table graph that we got. After that, we are checking for the missing values. There are no missing values. After that, we are going to take our data set and split that into training and testing. Here I got for the training 80% and testing 20%. After splitting this one, we are going to use the shape. We are going to shape. After that, we are going to take using the random forest classifier. I'm going to train the model. Here, this is where initialize and training random forest model. Then after evaluate the accuracy I get 0.76. After, I'm going to calculate the precision and the recall. Here is the precision and the recall which I got. Then I'm going to calculate the root mean square error and the coefficient of determination. So as we know, the lower the root mean square error is better, and the highest of the coefficient of determination is better. So here 0.43, that means R squared, or the coefficient of determination is higher. That means this is better. And lower the root mean square error is better. Here it is 0.36. Now let's move into the neural network and let's see. Here, as same as in the previous random forest, here also we import pandas as PD, then loading our data set, after that printing our columns, then the headers. Again we are going to convert the string data into the numerical data. After that, same graph that we are going to plot. X-axis shows the heart disease and the y-axis shows the count. After that, we are checking again the missing values. There's no missing values. Then again, we are going to split our data set, 80% for the training and 20% for the testing. After that, here I'm going to use the MLP classifier and to train the data. Here the training process is happening using this. After that, when calculating the accuracy, it gives 0.85. Previous one we got 0.76, that means 76% accurate, and here 0.85 means 85% accurate. After then we are calculating the precision and the recall. Then coefficient of the determination. Here the precision is 0.88, recall is 0.71, root mean square error is 0.38, r squared is 0.38. So again I'm going to remember, the lower the RMSE, that means root mean square error, is better, and higher the coefficient of determination is better.